in the last video, we looked at a vector field. I'm going to look at a few more. So here, let me see. All right, let's see this one. This is a vector field of 1y. So as you see, you move 1 to the right and y up. If this is 2, you move 1 to the right and 2 up. If this is 4, you move 2 to the right and 4 up. I mean 1 to the right and 4 up. Right? In a case where you have 5, you still move 1 to the right because this is saying 1 to the right and 5 up. So to the right is always 1. That's why you see the vectors getting steeper and steeper, because if you imagine the vector to be the hypotenuse of a right angle triangle, right? And the base of the triangle is always 1, but the height is getting higher and higher, then the hypotenuse would keep getting steeper and steeper as you go up. Alright? Because this width is always 1. So this is a vector field 1y. Let's look at another one. It's a vector field negative xy. Alright, negative xy. Interesting. Now here, you have, for example, in this case, x would be zero along here. So it's negative 0, which is 0, and then you go up y. Alright? 0 would be right in this area. As you go to the right, at 1, positive 1, you have negative x. So it should be pointing to the left, and then y up. Now, negative x. All of these are on the positive side of x, you know. This is x is 0, this is the origin, right? Right here. Because it's a negative x, the arrows point in the x direction and the opposite. That means on the right, on the positive side, they should point to the left in the negative direction. And then you go up y. So, when x is equal to 5 and y is equal to 7, then at 5, 7, the vector that you draw must be 5 to the left, 7 up. So the vector would look like this, right? At when x is 10 and y is 10, you say 10 times negative 1, negative 10. So this is negative 10 to the left, horizontal component. The vertical component will be 10 up. So you have the vector looking like that, right? When you go over to the negative side of the graph and say you have x is negative 3 and y is 2, then you have positive vector, because you should switch the sign. It's negative x and x is negative 3, so negative 3 is positive 3. The vector should point so that the horizontal component is to the right and the vertical component up. So the vector would look like this. Alright? So here, it's negative x, y. Alright? Close to the close to 0, right? Say at 0.1, you notice these vectors, they're almost level because x is 0.1 is a small value, right? Y is a small value as well, so they're almost level. As you go move outwards, say x is 1, 2, 3, 4, 5, these vectors get longer horizontally because x is increasing, but y remains the same. So they have the same gradient, the same steepness, all of these vectors here. But when you go up now, y gets large, so it's very steep. You notice, for example, in this vector, x is a small value, so it doesn't move much to the left or right. But y is a large value, so it's very steep, right? So that's the vector field in this case. Let's look at another vector field. Let me open it here. x1. So the height of all these vectors is 1. It does move up more than 1. As you move to the right, x gets larger and larger. So the vectors horizontally get longer and longer, but vertically they remain at 1. So it's x in the x direction in the horizontal and 1 in the y direction, the vertical, right? Same thing over here when x is -2, -4, and so on, right? X gets longer, but y doesn't. Y is always 1. So what you're looking at is the horizontal component is just 1, and you have x like this. When you, well, if you're considering over to the right, over to the positive side, right, you have the vector field is x1. So when this is 1, x is 1, y is 1. Horizontally 1, vertically 1. So the vector is this. So you have this vector. Say you're at 5, x is 5. But y remains 1. So this height still remains. Right? So the vector only gets longer horizontally, but you have your up and down, the rise remains at 1. So that's why this vector field looks like this. The further out to the right you go, the longer x gets. But the further up you go, it doesn't make a difference because y is fixed at 1. Alright? Let's look at this plotted vector field. This is x0. So x, as you go to the right, x gets larger and larger. So the vector in the x direction gets longer and longer. But guess what? It doesn't move up or down because y is always 0. There's no rise. In this case, on the negative side, x gets longer and longer pointing to the left, but you have horizontal vectors here because y is fixed at 0. There is no rise, only run. Alright? Let's look at this one. xy. Now here, the gradient of each vector is 1. Well, no, not necessarily 1. Of each vector, when x is equal to y, at 4, 4, the gradient would be 1. At 4, 4, the gradient of this vector is 1. But guess what now? What happens? As you move to the center, x gets smaller. So So the horizontal going left or right, the horizontal distance is small, but y gets larger and larger. So these vectors here get steeper and steeper. So the gradient is more than 1. What happened with these now? Y is small. When you go closer to the x-axis, y gets smaller and smaller. As you move to the right, but you remain close to the x-axis, x gets longer, the run gets longer, but the rise remain very small because we're close to the x-axis. So when x is 0.01, it's almost horizontal, but you can move left or right and you get almost horizontal vectors, right? Even though near to the x-axis, I mean y, did I say x earlier? Y is small near to the x-axis. For example, 0.01, very small value. Now, you hardly have any rise because you don't move up very much. But as you move to the left or right, x changes. As you move to the right, away from the origin, x increases. So you have the vectors get longer in the horizontal direction. As you move to the left of the origin, they get longer to the left because x gets more and more negative, but y remains. In order to get the vectors steeper and steeper, you'd have to increase the rise, increase y. So as you move upwards, these vectors get steeper and steeper. Alright? So here, that's yet another vector field. So these were the vector fields that I have. So you get an idea what the vector field is about. Now, here, we're going to look at doing a line integral in a vector field in the next video. So I'll see you.